What if a $13 billion warship suddenly had to leave the ocean? The reason behind it will shock everyone watching. This ship weighs 100,000 tons, and it is built to stay at sea. It is 1,100 feet long, longer than 3 football fields. Yet for 15 months, it sat locked inside a dry dock. That is not normal for a ship like this. The USS Gerald R. Ford is the newest aircraft carrier ever built. It can launch 270 aircraft missions every single day. It produces 3 times more power than older carriers. It launches jets using electromagnets, not steam. So why was it forced out of service? The trouble began at sea, without warning. A critical bearing failed inside the propulsion system. Alarms sounded, and full power was at risk. One wrong choice could damage the entire ship. Over 1,000 workers were sent in to fix the failure. If this carrier stayed offline, global presence would shrink. Rivals were watching closely, waiting for weakness. Delay was not an option, not right now. Today you will go inside the dry dock. You will see what broke and how it was fixed. When 100,000 tons float again, the moment matters. But what caused this failure in the first place? The story began with a plan to build a new kind of carrier. USS Gerald R. Ford was made to be different from older ships. It was built as the first ship of a new group. Every main system was designed again from the start. This carrier was built to work better at sea. That was the main goal. Many years of work went into this ship. Engineers tried new ideas that were never used before. Sailors knew they were serving on something special. This ship was built to lead the future. Its size shows its power. It is over 1,100 feet long, longer than 3 football fields. It weighs 100,000 tons when fully loaded. It makes 3 times more power than older carriers. It can launch 270 aircraft missions in one day. That gives it a big advantage. Think of it like new technology, replacing old tools. Older carriers worked, but this one works faster. Many tasks are automated, so fewer people are needed. It uses 600 fewer crew members than older ships. This saves space and resources, but new ideas bring risk. This ship was built to change things. Change does not always go smoothly. If it works, it changes sea power. If it fails, the cost is huge. That pressure was always there. Then something broke when it should not have. A serious problem appeared, and it was found just in time. It was early 2018, and the carrier was out at sea for testing. Everything looked normal, and systems were running fine. Then alarms started sounding inside the ship. Something had gone wrong. The failure came from a thrust bearing, a critical part. This part sends power to the propeller shafts. When it failed, movement was at risk. That was a serious danger. For the crew, this was a nightmare moment. A bearing failure is not small. It is major. If ignored, it can destroy the entire system. There is no room for delay here. The thrust bearing handles heavy force every second. It deals with heat, pressure, and motion together. When one fails, the whole line is unsafe. Think of it like a car axle, holding the wheels. If it cracks, the car cannot move safely. The ship had to slow down and return with less power. This was not bad luck. Tests showed the bearing was faulty from the start. A manufacturing mistake caused a hidden weakness. The failure appeared under real stress. If it failed fully at sea, the ship could stop. A stranded carrier would be a major risk. The danger was avoided, but the problem stayed. The only option left was dry dock. But lifting 100,000 tons is not simple. The next step was moving the ship into dry dock. This is not like parking a car, and nothing is simple here. USS Gerald R. Ford had to be guided with extreme care. One small mistake could cause huge damage. That risk was real. The dock stayed full of water during the first move. 6 tugboats pushed and pulled from different sides. The ship had to line up perfectly, measured in inches. There was no room for error. Once aligned, workers secured the hull. Large wooden blocks were placed under the ship. Each block sat at a planned spot to hold the weight. If even one block was wrong, the hull could bend. That danger stayed constant. Positioning was only the first step. Next came draining the dock, very slowly. Over 100 million gallons of water had to leave. As water dropped, the ship settled onto the blocks. Engineers watched every movement without pause. If the ship shifted, the damage could be severe. This process took hours, not minutes. Every sound and reading mattered. When the dock finally dried, access was complete. Only then could repairs begin. and what they found inside surprised many. Once the ship was dry, workers could finally reach the damaged bearing. This was not a quick swap, it was careful repair work. Every step mattered because the ship uses nuclear power. One small error could stop the entire project. That pressure was heavy. For the workers, this job felt personal. They knew the ship had to return as soon as possible. Every lost day reduced global presence. Failure was not an option. The repair meant removing the old bearing piece by piece. A new bearing was installed, then aligned with extreme care. The tolerance was tiny, measured in thousandths of an inch. Precision decided success here. Huntington Ingalls Industries led the repair work. More than 1,000 workers joined the effort. The job lasted 15 months, day and night. Think of it like surgery, slow and exact. You cannot rush, and you cannot guess. While repairs continued, other systems were improved. The hull was checked, and upgrades were added. The ship became stronger than before. If the repair failed, delays could last years. That risk stayed constant. After 15 months, the moment arrived. The ship was ready to float again. But leaving dry dock brings new danger. After 15 months of repairs, the next step was leaving dry dock. USS Gerald R. Ford was ready to return to the water. This step looks simple, but it is not. One wrong move could undo months of work. That risk stays high. The dock is flooded slowly, not all at once. Water rises over several days to protect the ship. If water rushed in, strong currents could form. Those forces could cause damage. As the water climbs, the ship starts to lift. It floats off the blocks a little at a time. Engineers watch closely, second by second. The balance must stay perfect. Think of it like lifting glass, slow and steady. If you rush, something will break. Patience controls everything here, but the ship does not move alone. Tugboats guide it at feet per minute. Every push and pull is planned. No sudden motion is allowed. If the ship tilts, damage can happen fast. If it stays level, the rollout succeeds. This moment brings relief and quiet pride. But floating is not enough. The real test comes next. Can it perform under pressure? Floating again does not mean the ship is ready. Every major system must prove it works. Testing begins before any mission is approved. This phase decides everything. The propulsion system is tested at different power levels. Engineers watch heat, vibration, and output closely. Any strange sign stops the test. There is no guessing here. The ship runs fast cruise drills while still docked. The crew acts like they are at sea. Systems run full time, day and night. Problems are easier to fix before sailing. Then comes sea trials, where real stress begins. The ship goes to full speed in open water. It makes sharp turns, stops, and restarts. Each move tests the repair. Think of it like testing a car after engine work. You do not drive slowly, you push it hard. That is what happens here. But propulsion is not the only focus. Jet launch systems are tested again and again. Weighted sleds are fired off the deck. Each launch adds stress like real aircraft. Only repeated success allows approval. If all tests pass, the ship is cleared. If one test fails, repairs start again. Everything depends on this moment. But why is this ship so important right now? This ship is more than metal. It is a strategic tool. Aircraft carriers change decisions before fights even begin. When one is active, pressure shifts instantly. That impact is real. Carriers allow action far from home shores. They give leaders options no other force can provide. The return of this ship restores that freedom. That matters right now. One carrier group can affect huge areas at sea. Its presence alone can stop risky moves. Allies feel safer and rivals pause. That balance prevents conflict. This carrier can launch 270 missions in a single day. That endurance allows long operations without rest. Few forces can match that. Think of it as a moving airbase, always ready. It does not need permission or local support. It carries its power wherever it goes. But this ship also teaches lessons. It tests new systems for future carriers. Each fix improves the next ship built. That shapes the next decades. If this ship succeeds, strategy is confirmed. If problems return, plans may change. The future depends on results. Behind all this power, real people made it work. Who were they? And what did they face? Behind every system, there are real people at work. Workers, engineers, and sailors made the repair possible. Their effort turned plans into action. That work matters. For many workers, this was more than a job. It felt like a mission with real responsibility. Every task counted, no matter how small. There was no room for mistakes. More than 1,000 workers took part in the repair. They worked for 15 months, day after day. Over 800,000 hours went into one failed bearing. That level of effort is rare. Even while in dry dock, the crew stayed sharp. They trained and prepared for return to sea. Readiness never stopped. Think of the workers like a pit crew, fast and precise. They work in tight spaces, under heavy pressure. One error could undo everything, but their names are rarely known. The ship gets the attention, not the hands behind it. Without these workers, nothing would move. Their pride shows in the final result. Quality depends on people, not machines. Now the ship is ready, and the focus shifts forward. What comes next will decide everything. After 15 months, the carrier is finally back. It is floating again, tested and approved. The ship is ready to return to duty. That moment matters. For the crew, this feels like a fresh start. The repairs are behind them, and focus returns forward. Training is complete, and confidence is back. Now performance matters most. The carrier will move into key regions. Its presence changes behavior without a single shot. Allies feel reassured, and rivals take notice. That influence is immediate. Think of this return like an athlete coming back strong. The injury is healed, and the work is done. Now comes the real test. But this is not the end of the story. This ship is built for decades of service. It will grow and adapt over time. Each mission adds experience. If it performs well, the program is proven. If issues return, questions will follow. That pressure never leaves. This next deployment will be closely watched. Success builds trust. Failure creates doubt. So one question remains. What does this mean for the future at sea? This ship stands for more than power. It stands for direction. It shows what long planning and hard work can build. Its return proves problems can be solved. That message is clear. For the country, this ship brings pride. It shows commitment to safety and strength. It sends a signal that promises are kept, that trust matters. This carrier is the first of 10 planned ships. Each new one will improve on the last. Lessons learned here shape the future. That progress continues. Think of it like first-generation tech, new and untested. Early versions struggle, but change everything. Later versions improve and last longer. That pattern fits here. But a hard question remains. Will carriers stay dominant or face limits? New weapons and drones are changing warfare. The answer is not settled. If carriers adapt, this ship is a success. If they do not, critics will be loud. The next years decide that. This ship is built to serve for 50 years. That future starts now. The mission continues and the story moves forward. This return is not just about repairs, it is about resolve. A $13 billion ship broke, but it was not abandoned. The problem was faced, studied, and fixed. That choice defines everything. This carrier stands for innovation, even when risks appear. It shows refusal to quit, even under pressure. Second place was never acceptable. That mindset matters. Many see this ship as a weapon, built for conflict, but it is also a promise, made to those who serve. It protects missions, allies, and open seas. The tool matters, but the purpose matters more. Failure did not end the story. Failure became a challenge, not a defeat. The ship broke and it was repaired. Now it is stronger, not weaker. That lesson is clear. Watching it float again shows determination in action. 15 months of work led to this moment. Thousands of hands made it possible. This is what excellence looks like. Remember the alarms at sea and the fear. Now remember the outcome and the return. The journey is complete. The ship is back and ready. Innovation carries risk, but progress demands it. The future was tested and it answered. The carrier is floating again, tested and ready. The repairs are complete and the mission continues. Strength has returned and confidence follows. That matters today. You went inside the dry dock step by step. You saw what broke and why it failed. You saw how it was fixed with care and time. Now you know why it matters. This was not just about ships or machines. It was about skill, effort, and responsibility. It showed what focus and teamwork can do. That lesson stays with us. If this story helped you understand more, show support. Like the video and subscribe for more updates. We share detailed stories like this every week. Your support keeps this going. Type proud in the comments if this story meant something to you. Which part impressed you most? The repair, the rollout, or the testing? Share your answer below and join the discussion.